Okay, now we're recording. All right, I'll just say here at the beginning, I'm David Stevens with the UDOT Research and Innovation Division. Glad to welcome you all to this presentation meeting today. Our main speakers, our presenters are Steve Bartlett from the University of Utah and Kevin Franke from BYU. And they'll be presenting information from some recent studies on developing new liquefaction triggering and lateral spread hazard maps for 4 different counties in Utah, Weber, Davis, Salt Lake, and Utah counties. And we have on the line today, or invited, individuals from Utah Geological Survey, as well as UDOT and some consultants and several water agencies, some of whom have been involved in some of these studies over the years with funding and just technical input. So with that, hopefully we can have a good dialogue here. And I'll hand it off to Steve Bartlett, and then you can hand it off to Kevin Franke to talk about their parts about the geodatabase data collection, as well as the map development. And then we can answer questions along the way, and if that's okay for the presenters, or we can wait till each one of them is done. You can also enter your questions in the chat box. So Steve, go ahead.
Well, thank you, David, for the introduction. Thanks for all that are attending. I know these are busy times. I wanted to, in this first slide, just acknowledge some of the people who have been involved with the Utah Liquefaction Advisory Group over the many years. This final product that we're kind of showing you today is, still work under the auspices of the Utah Liquefaction Advisory Group. We began in about 2003 in the first meetings, primarily with the University of Utah and Utah State University, discussing some of the plans for doing liquefaction mapping in the urban counties of the state of Utah. Later then, as we progressed, Brigham Young University joined the team. I have Oregon State here also because Dan Gillens became a contributor after he graduated from the University of Utah and went there as an assistant professor and contributed a lot to the mapping efforts too. He and Mike Olson, one of my former students, also are both at Oregon State. Of course, this is done under the auspices of the Utah Geological Survey. That's where ULAG was organized in collaboration with them. And mainly our funding over the years has come through the National Earthquake Hazard Reduction Program, with additional matching monies from other agencies such as UDOT, Weber Basin Water Conservancy District, Central Utah Water Conservancy District. I also need to mention that about 5 years ago, we were doing some work with FEMA and the Utah Department of Public Safety in terms of publishing some of the maps and getting them ready for hazard ordinances. So this has been a long effort, and I do believe I should mention all the others who have participated on the ULAG board. I can't mention all of their names, but we've had several consultants and others from the outside helping and steering and guiding these efforts. So that's just kind of a brief history of ULAG, and I think we're, at least as I reflected back on the main objectives that I'm going to show you here, I think you'll see that we've probably met most of our objectives in our mapping. That doesn't mean we're done. I think always maps can be improved and modified as research and more data become available. But I think as far as map development, we've met some of the original objectives we set out in 2003 and 2004. So just a quick review of liquefaction. Liquefaction is caused when you have saturated, primarily granular sediments that are loose. The earthquake shaking is usually severe enough, water table shallow, and these, the fabric of the soil tends to kind of collapse and cause pore pressures to be elevated, and you have manifest either liquefaction effects at the surface like sand boils and other types of ground displacements. So it's really a problem, certainly when we get infrastructure involved, which can be heavily damaged by the ground settlement and horizontal movement caused by liquefaction. Some of the effects, certainly ground oscillation occurs where there may be not large displacements in any one direction, but the ground just oscillates back and forth while it's in the liquefied state as long period waves, primarily surface waves, are coming through after, during and soon after the earthquake. So this is well known, and it's thought that the Marina District in the Loma Prieta earthquake in 1989 suffered severely from a lot of ground oscillation, causing a lot of damage to some of these wooden Victorian homes that you see in the Marina District in San Francisco. Other things that can happen, certainly as the soil liquefies, it then reconsolidates as pore pressures dissipate, usually to a lower void ratio, which causes ground settlement. So the ground settlement can be quite disruptive, particularly as you see here. This is, ground settlement occurring during the 2011 Tohoku earthquake, and its severe differential settlement can not only damage structures, but it certainly, in terms of highways and pipelines, damage the pipelines and bridge approaches. Another thing that occurs during liquefaction is bearing capacity failure. Here, the soil loses its capacity to support weight. So if you have shallow foundation systems or buildings or other heavy types of structures on them, then they can settle and rotate during the earthquake. The one that a lot we've focused on in this mapping effort is called lateral spread. Lateral spread is where we have a liquefied zone somewhere at depth. It provides the ability for the soils to move primarily horizontally, either down a slope or towards a free face like a river channel or a canal. And these horizontal displacements, again, are very damaging to infrastructure, as we've learned from many previous earthquakes. And maybe last, but also important, is flow failure. Flow failure is kind of a continuum like lateral spread. It is horizontal displacement, but here the ground slopes are either steep enough or the loss of strength is so severe that the ground actually flows and has very disruptive displacements of several tens, if not hundreds of feet, which is very damaging. And it's happened a few times during major earthquakes, 1964 Alaska earthquake, several lateral spreads, both in Valdez and Seward, Alaska, and most recently in Palu, Indonesia, had suffered also from flow failure. So realizing that Utah is susceptible to liquefaction due to its moderate seismicity and its also fairly recent geological sediments, predominantly in the alluvium-filled valleys, then we launched the Liquefaction Advisory Group to help maybe do some better mapping of some of these hazards. So this is from our 2003 meeting. Objective 1 was to develop probabilistic-based liquefaction hazard maps for urban counties in Utah. Probabilistic meaning that we wanted to quantify both the uncertainty and probability of liquefaction due to the sediments themselves, and also the probability of occurrence of different earthquakes of different course magnitudes and levels of strong ground motion. We identified the counties we felt that was best to proceed at that time: Salt Lake County, Utah County, Davis County, Weber County, and Cache County. The types of maps we wanted to focus on were those that combined both the seismic hazard and the ground or sediment hazard. And the types of maps we have produced over the years are liquefaction triggering maps. These indicate whether liquefaction will trigger or not. You can either do this deterministic with a factor of safety or probabilistic with a probability of liquefaction. We also were encouraged predominantly by Les Yaud to really focus a lot on lateral spread displacement hazard maps, because it's felt that lateral spread is probably the most severe cause of damage during, at least due to liquefaction during earthquakes. So we've done a lot of work on lateral spread displacement maps, both deterministic and probabilistic based maps. And then also we have done some liquefaction-induced ground settlement maps, only for Salt Lake County, but those have been released. Another objective that we wanted to do was develop ArcGIS programs for implementation of the procedures. We realized that the data requirements are intensive here, both on the earthquake side and the soil and topography side. So we knew that we had to do this through computer methods. We also, at that time, were coupling our estimates coming from the probabilistic seismic hazard analysis from the National Strong Ground Ocean Mapping Program sponsored by the USGS. So we wanted to couple our at least seismic estimates coming from that program. And we had hoped to develop user-based algorithms so that the maps could become living maps. I think we're partway there, but it still takes a lot of knowledge to be able to run some of these algorithms to produce these maps. Objective 3, we wanted to establish and populate a subsurface geotechnical database for public use. We've been quite successful in that because we've needed that data to do the mapping. So a database now exists first for Salt Lake County, then it was developed for Weber County, then Utah County, and now most recently Davis County. So we have that. The total number of boreholes that have been collected and identified by geological unit is probably around 2,600 now, boreholes. Of course, these would be useful for geotechnical evaluations, land use planning, research, and we identified potential partners from getting that data, UDOT and other counties and cities. Of course, we've been also partnering with the LDS Church and others and geotechnical firms of getting data that are in the public domain. I should have mentioned that that database is developed and available for use. Education and outreach became an important thing. We wanted user-friendly maps so that people could understand them. We wanted to assist counties and other municipalities in developing ordinances based around the maps and outreach seminars and websites. I should mention, as part of the FEMA money that we obtained about 5 years ago, we did do a lot of liquefaction training and outreach. The Utah Geological Survey developed a website and helped us with some short courses. I went out to some of the high schools and talked about earthquake hazards and certainly talked about liquefaction. I won't go into all these maps that's been produced over the years because I think it would take too much time, but I do want to mention that we have, liquefaction triggering maps, both for scenario and probabilistic based triggering maps that have been developed over the years. And then the lateral spread displacement maps, as you'll see many today. I think these are certainly state-of-the-art that will be of interest not only to agencies like UDOT and public utilities, but for future planning. Just a little bit of background. When you get into mapping, I think you have to understand that you're doing regional studies, not site-specific geotechnical studies. And so you have to begin to combine geotechnical factors with other types of information to develop maps. And some of the work done by Les Yaud many years ago certainly categorized the susceptibility of geological deposits, not only by their depositional environment, but also by their age. And so this is a relative ranking of, liquefaction susceptibility, where we see, the depositional environment like floodplain, alluvial fan, so on and so forth, and the age. And it's still useful in relative terms. when you're doing mapping to kind of keep in this framework. Also, when Dan Gillens and I were looking at mapping Weber County, where we knew the geotechnical data would be less amount of data than we saw in Salt Lake County, we certainly realized the need to put the geotechnical data within a susceptibility framework. And we used kind of this general framework to categorize the boreholes and place them within the geological units and the relative susceptibility. And I think it was a very powerful idea, and it helps us maybe map in areas where we have less geotechnical data. Just to show you the influence of depositional environment, it is known that river channels are notorious for causing liquefaction and lateral spread. During the 1964 Nagata, Japan earthquake in Nagata itself, on the left-hand side of this figure, I don't know if you can see my arrow, but you can see the old river channel of the Shinano River shown with dashed lines. And it was pretty clear that looking at the displacements from that earthquake that were done using photogrammetric techniques, that most of the large damaging lateral spread displacements were restricted to the river channel deposits. So understanding the subsurface geological environment becomes primary, I think, in doing any mapping. So this is just a map of Salt Lake County. I'm just presenting it because it's what I had readily available to me, but you see the geological units identified here, and you can talk a little bit about the relative susceptibility. And then you see on the right-hand side the borehole data that was collected in Salt Lake County. There's almost 1,000 boreholes that were in this data set. You can certainly see the transportation corridors are well delineated due to the data coming from UDOT, but also there are other boreholes that were gained. So I think the challenge really of regional mapping, like we're doing, is learning how to combine the geological data with the geotechnical data and deal with uncertainty. And so much of our development over the years, I think, is still focused on how to make that process more defensible and more quantitative. Of course, some of the geotechnical data, there was an abundance of standard penetration data that was taken over the years. So we did our best to get that data in the data set and use as best we can high quality data where we had a certain amount of information about the hammer that was used. A lot of UDOT data that we were obtaining also had hammer energy measurements on them. So we knew that, which was very important. And also, along with the standard penetration flow counts, it was important to get some ideas of the soil descriptions that were there, the layering, the depth of groundwater. And when possible, we were also, when we developed the data set, assigning those geotechnical layers to geological sedimentary layers, classifying them whether they were recent alluvium or, Bonneville deposits or whatever they might be, so that we could have a rough estimate of their age and depositional environment. We have used some CPT data. It's a little harder to incorporate in the mapping efforts. Not that it's not good data, it's just that some of the equations that we're using to predict, particularly lateral spread, use soil factors, and it's sometimes you have to infer what might be the soil factors from the cone penetrometer data because you don't always have a direct measurement of them. But Dan Gillens in his dissertation, I think, came up with a good and rational method of combining CPT and SPT methods, which we did use quite extensively in Weber County. But I won't get into the cone penetrometer. I think most of you are familiar with it, but certainly it gives us an idea of tip resistance, sleeve resistance, and pore pressure measurements, which can help us identify the groundwater. And it also is a very good stratigraphic tool when placed in, somebody that understands both the geotechnical and subsurface geology. Of course, one of the primary things of gathering this data is to look at penetration resistances. There are correlations that identify whether you may have liquefaction or may not have liquefaction, which are predominantly based on the penetration data, SPT, CPT, or you can do this with shear wave velocity information. And then you have to have an estimate of what was the cyclic stresses caused by the earthquake, which is shown on the left-hand side of this graph. So initially, many years ago, Harry Seed, Ignacio Arango, which was his student, and Ed Idris developed some boundary curves to find sites that liquefied and did not liquefy according to penetration resistance and cyclic stresses induced by the earthquake. We persist in this methodology. However, we've made several refinements and certainly made them more probabilistic. And there's current efforts to, again, revisit these curves as part of the pure next generation liquefaction project. Of course, you have to, I think three-dimensionally when you do mapping and go into the subsurface and identify layers that might be critical for liquefaction. This just shows a typical borehole where you might have soil layering, measurements of penetration, and then some type of analysis that tells you where the liquefaction may have occurred. So it's important to keep this in mind because not only, borehole tells you what might be happening at that particular location, but for something like liquefaction-induced lateral spread, you need continuity of layers or continuity of a given layer to actually cause the lateral spread. So continuity becomes a big issue when you're doing mapping. Groundwater estimates are needed. Depth to groundwater. Most of the data that we've done for groundwater depths in the analysis would be coming from the boreholes themselves. There certainly is fluctuations in groundwater table with time, both seasonally and over many years. So that has to be somewhat taken into account in your uncertainty analysis as you develop these maps. Topography plays a large role in lateral spread. Certainly the sloping ground in the vicinity where the liquefaction may have occurred, or if you're approaching a major channel or canal or a free face, such as a bluff, then you need to take that into consideration. This just shows the 20-mile river and how badly the highway bridge was damaged from lateral spread. It's completely collapsed. The adjacent railroad bridge did not collapse because it's more of a continuous type of structure. But what we learned many years ago is that the proximity to these river channels and the free face caused by the channel itself heavily influences lateral spread. So if you have these in the mapping domain, these have to be included in your digital elevation model. So here's just kind of an interesting thing that Mike Olson did some years ago. I think this is still a reasonable representation of kind of how you have to start to combine data. The black dots show at that time the borehole data that we had available for North Salt Lake County. You see overlaying on the digital elevation model the geological map and then the borehole location. So it's this kind of combination of information that one uses to produce the maps. Let me talk a little bit about uncertainty. Certainly there's geospatial uncertainty associated with boreholes because even if you're within the same geological unit, there's variability within that unit. So that has to be taken into account. I had Dan look at this from a geostatistical perspective. This is called a semi-variogram, and what it shows, I won't get too much into how you do these types of variograms, but basically you can see after about 100 meters, most of this data plots about at kind of the same amount of variance. which means that there's probably not any strong spatial correlation. But within about 100 meters, there seems to be spatial correlation. So in some of the mapping processes we've used, if we were within about 100 meters or less, we would use the nearby data as estimates because it was the most reliable and still could be spatially correlated. But if you get about 100 meters distance, there's probably not a lot of spatial correlation. So to represent the geotechnical factors within a geological unit, then you probably need to, for data that are spaced further than 100 meters apart, treat them all as equally likely and equally probable and sample from a larger data set. If you are dealing with this uncertainty, then whatever types of information you're using, whether it's penetration resistances, fines content, mean grain size, whatever, you can develop for that geological unit the distributions of the important geotechnical factors. And then if you're, beyond this range of spatial correlation, which most of the mapping is going to be, then you randomly sample from that geotechnical data set according to that particular geological unit. So that's why it's important to place the geotechnical data both not only superficially where it may be in terms of a geological unit, but with depth, because as you go down a borehole, there's a chance, obviously of changing from, maybe Holocene deposits into Pleistocene deposits and different types of depositional environments. So that all has to be kept track of if you're going to use geological parameters as the primary classification from which to sample from. So you can random sample once you do this as equally likely and develop a more robust statistical sampling of the potential variability. And these were kind of some of the things Dan was doing some 8 years ago. We also had to modify the liquefaction hazard mapping, the lateral spread mapping for the type of equations. So Dan did that part of his dissertation. We took the Youd and others. It was initially my dissertation, and then it was modified slightly by Corbett Hansen, and then Dan modified it again for soil type and the use of CPT data, and came up with a modified regression analysis. I won't trouble you with this, but it was necessary to complete the mapping efforts. What we did with Dan's most recent work is when I did it, I just used granular soils, and I didn't really change. I had granular soils and I had fines content and mean grain size. Dan looked at it by certain types of soils. Here, as you can see, 1 through 5, how he classified soils, and then within the regression equation itself, you can see that there are parameters put in for each of those different variables. Then he came up with the idea of how to convert them kind of to a clean sands version. I haven't presented that equation, but it's important to realize that we modified the regression equations for more regional mapping purposes. And when we checked what he did versus what I did some years ago, it's pretty clear that his modifications really didn't change dramatically the predictability. Generally, these regression equations predicting the amount of lateral spread are plus or minus a factor of 2 in the predictive power. There are some outliers that you can see that fall out of these bounds that I'm showing above and below the best or perfect prediction line. You can see that about 90% of the data fall within plus or minus a factor of 2 of what's predicted by the equations. We're currently looking these data sets and revising in the future probably some of these equations as part of the pure NGL project. Both myself and Kevin Franke are currently putting together the final data sets for some of the lateral spread. I think I'm going to skip this because this I put in, but this is really probably more what Dan and Kevin need to talk about. As we developed how to deal with uncertainty, changed the regression equations, and of course Kevin came in and helping us tremendously with how to incorporate the seismic loading or seismic demand in the probabilistic calculations. We developed a more elaborate and probabilistic process. And this is what you're going to see today as we show you the lateral spread maps for all of the urban counties that I mentioned in my first slide, except for Cache County. We have not done this for Cache County. You will see how this is done. So this is really more into map production. I would just put out that what we were doing most recently to support this project, we being the University of Utah, was gathering the data in Davis County. But the grant that we received from the USGS, which we did this work under, was not only to gather data in Davis County, but take the mapping process that was developed for Utah County and apply it to, Salt Lake, Weber, and Davis counties. So that's quite an effort to go back and do all those counties again with probabilistic techniques. This is some of the data for Utah County that was gathered by Kevin and his graduate students, and the mapping that was gone on in Utah County, which I think will probably be discussed in the efforts that Kevin's going to now follow up with. So I believe I'm done. I don't know if it's good to pause for just a moment and see if there's any questions from me, and then we'll let Kevin proceed, or we can wait till the end, David, and answer questions jointly. It's up to you.
I think we could pause for a minute, or a few minutes, and see if there's questions about your presentation or the data collection or databases that are available. Sure. Would anybody like to ask a question for Dr. Bartlett?
You can call me Steve, David.
Oh, Steve Bartlett.
Hi, this is Steve over at the UGS. Just so you're aware, we've got new quaternary mapping of the Salt Lake Valley, except for the Midvale Quad.
Okay. Yeah, I think we'll have to reflect and see how much changes have gone in the quaternary mapping. And I always consider maps kind of a living animals. And so as the mapping improves and as the database, the geotechnical database improves, I think there are opportunities to, and again, as the USGS changes their seismic demand, which they tend to do about every 5 years, I think there's need to update maps. I'm not sure whether the processes will change a lot, though. I think we're getting to the point where the methods how we do this will stay pretty constant. There might be some, changes in the future too with that, but I think my impression is about once every 5 years, some of these maps should probably be updated, but we can talk about that in the future. Salt Lake County, I think, was done with, this was done with Barry Solomon some years ago. So, that was probably mapping available 10 years ago.
Okay, great. Thanks for the question and answers there. Any other questions for Steve Bartlett on his presentation? Maybe. Oh, was there someone? I guess I'll ask a kind of a follow-up question to what Steve Bartlett, since there's at least two Steves on the line here. I'll keep saying Steve Bartlett. Okay. What you said about the database or databases. I'm not sure if it's all in one database, but for these 4 counties, the borehole data, that you said that would be available to others that may want to use it for additional studies or analysis. I'm aware that UGS and UDOT have partnered over the past year or two on kind of a pilot effort to develop a three-dimensional geodatabase for at least one, starting with one quad in Utah County, with available borehole data that UDOT could provide and some other sources. I think that's may have transitioned more to a 2D web app, kind of simplified version, since the 3D seemed to be maybe more than we could handle. But anyway, I guess I'm just bringing that up because perhaps Steve Bowman would want to chime in on whether you think this database. I'm assuming these are completely different databases too. I don't know if you two have actually exchanged data between your databases before, but maybe now would be a good time if some of that data could be shared across the academic and practice lines. Steve Bowman, do you want to chime in on any of that? Whether you would want to tap into that?
Well, I think that we're probably at a point that we could kind of merge the two databases. We've expanded out from the Lehigh Quad, which was the pilot project, and now there's about 2,500 borings and test pits and their associated lab data in the database. The reason that the web app is 2D is currently the ArcGIS online tools for 3D are pretty limited. And so we're really having a hard time with the limitations from Esri to get it to work right. And so we've been looking at some other alternatives beyond that. We're hoping to have the 2D part done this summer and then see what we can do on the 3D. You can do it on the desktop, okay, but when you go to the web, that's where the 3D part starts breaking down. But the plan here is to keep adding data to the database as Jessica, who's also on the call, and others are doing their hazard map sets. And so, we'll just keep adding data, and, if Steve and others, we can add data from other databases, and it may make sense just to merge them into one, to keep the maintenance down. It's easier to do one than two.
Yeah, I don't disagree. I think, correct me, Dan, if I'm not wrong here, Dan and Kevin, but I think our current database is still in Microsoft Access. Is that right?
Well, we as part of the paper we recently published, I believe we had to upload the database to a publicly available location. Isn't that correct, Dan?
Yeah, that's right. It's available through a server at the University of Texas, and the name escapes me right now, but it has a DOI number. It's publicly available, and I could track that information down here in a second.
It's design safe, is that right?
Yeah, it's in design safe. That's it. Thanks, Kevin. That's right.
So I think the database itself is primarily quantitative in that it's numerical values. I don't know, over the years we have tried to, when we got these from different geotechnical reports, scan the documents that's supporting it. So I think we're a point where merging would make sense, but I think there still might be some need to go back to the original reports and get some other raster images of some of the borehole logs and other things like that to make it more compatible with what you're trying to do with your efforts, Steve. But I think it would be good to do this. We certainly would make the data set available. It's already available.
So the database also links to scanned copies of the original geotech reports if they're available.
Right.
If not, it's not a requirement for the database, but if the data does exist, that link does exist to tie those together. So if you more information,
we certainly have referenced the original report from which the data came from. Whether we've got raster images, I would suspect maybe a lot of the our data sources you've already have in your data set or database.
Hey, Steve.
So,
Looks like Jessica chimed in and said that that UGS has the database that was used, and it is incorporated in their UGS database, and now includes 50,000 borings.
Yeah. Hi.
Oh, there she is.
Yeah. We do have the original data set that was used for the Salt Lake mapping, and we've incorporated that into our database of geotechnical data. And then as we've been continuing to enter for the UDOT project, we've gotten over 50,000 points right now. We still have more to enter, and we're kind of merging the Salt Lake database with what we've done for UDOT. And that's all in Excel and then can be put into a GIS. And then you can symbolize each location and view the samples taken at depth. So it's not visualized in 3D, but it is still essentially a 3D database. You just have to click on each point to see what's happening at depth. But we do have that data merged with our data.
Yeah, the database has grown, though. We have Utah County, Davis, and Weber County in it now also. So.
Yeah, this is Dan Gillens. I'll just say the database that we for this liquefaction studies, it's in Microsoft Access. It's also in Excel. I mean, I think we could we followed the same format that was used for the Salt Lake County, the initial study. So it's all kind of formatted the same, and it's available.
Well, great. Maybe that's sufficient for this discussion as far as knowing that that's available and that there's additional sharing that could go on between agencies. So thank you for answering that question and chiming in, everyone. Any other questions for Steve Bartlett before we move to Kevin Frankie's presentation? Okay, Steve, did you have any more to say before you pass it on to Kevin?
No, I think we ought to proceed.
Excellent. Thank you, Steve.
You're welcome.
Kevin, would you like to? Oh, I guess one of you needs to switch your screen to present now. Kevin,
I'll stop sharing.
Thanks. And Kevin, are you familiar with how to present your screen?
Yeah, let's see. All right. Should be seeing my screen now?
Yes.
Yes. Yes.
Okay. Perfect. Move this out of the way. All right. Thank you, Steve. That was a great introduction, and I'm grateful for the opportunity to be here with all of you guys today. It's I don't know if you're like me, but all these meetings from home is really, really challenging. My house is like a zoo, with animals running around, kids running around. It's so if you hear noise, just chuckle and we'll all grin and bear it. But I wanted to talk today a little bit more about the new maps themselves and the algorithms and the processes that went into developing the maps. And of course, this was done hand in hand with Dr. Dan Gillens on the call with us today. We developed and tested most of these methods in Utah County, and then we have applied them to the majority of the Wasatch Front, of course, minus Cache Valley. But I still think the development of these maps is going to be very significant for those of us along the Wasatch Front. So I don't need to cover too much of this, but it is helpful to understand where we've been in order to understand why we are where we're at. So for a long time here in the state of Utah, we've benefited from the existence of liquefaction hazard maps. And this was made possible because of Lauren Anderson and his colleagues and his students that in the early 90s developed these maps for most of northern Utah. And these maps have been used in countless engineering, design, and consulting projects. And they really were, for their time, quite a monumental feat. They were, as far as I'm aware, among the first maps to consider probabilistic ground motions in liquefaction hazard mapping, and they took the approach of like Steve described to us, of correlating the soil to mapped surface geologic units, which enabled the creation of maps across large regions, as opposed to having or requiring a lot of site-specific information. And they did incorporate whatever subsurface information was available. And they generally created some bins of liquefaction hazards. So these would be like very low, low, moderate, high, very high. And that's how they mapped all these. So what you're seeing here is a picture of Davis County, which was one of the primary focuses of this current study. These maps, however, did not consider any sort of displacement. There was no formal quantification of liquefaction hazard in terms of something like a factor of safety. And so there was quite a bit of subjectivity with these maps. So when we set out to refine and improve the procedure used for mapping, in incorporating probabilistic ground motions, we understood a couple of things. We first understood that our understanding of liquefaction as a phenomenon, and our understanding and our ability to predict initiation of liquefaction, as well as our understanding of susceptibility of soils, it's advanced substantially since the early 1990s. And we felt that the maps needed to reflect this advancement in our understanding. We also wanted to move away from these vague quantifications, these vague bins of high, moderate, low, for instance. And we wanted to be able to quantify the hazard in terms of numbers that could actually be measured or actually have a physical meaning, and also quantifying actual displacements, like horizontal displacements, would be better than just subjective bin categories. We wanted the probability levels, or we identified that the probability levels of existing hazard maps, like the Anderson and others maps, weren't compatible with the hazard levels that were specified in the current seismic design code. So this is, for instance, UDOT and most of the DOTs across the country. They design now to a 1,033-year return period, or that's a 7% probability of exceedance in 75 years. And that return period, the incorporation of that return period is fairly recent. And so the maps that were developed in the early 90s were corresponding to different probability levels. And then finally, there's a whole lot of uncertainties that those original probabilistic maps did not explicitly account for. Uncertainties in soil properties and ground motions, and also being developed from modern hazard estimation or quantification tools. So incorporating, for instance, principles of performance-based earthquake engineering. And so these were all things that we saw and knew that we needed to accomplish with the mapping project. And so, of course, I don't need to get too much into the background. I think Steve did a great job giving that of how the probabilistic liquefaction mapping project kicked off in the early 2000s, and then the individuals involved and the contributions they made to get us where we are. I thought it was significant in 2013 that that the ULAG made a vote, and that was to make the probabilistic liquefaction hazard mapping of the Wasatch Front its top research priority. And that enabled us then to obtain funding to test this new methodology on Utah County the following year. And then more recently, we were able to obtain funding from the USGS and NEHRP, as well as matching funding from UDOT in 2017 for the University of Utah and Brigham Young University jointly to map Davis County, the liquefaction triggering and lateral spread displacement hazards for Davis County, and then extend that to the existing data for Weber County, Salt Lake County, and Utah County. And so these maps, since 2017, we've been working closely with Dan Gillens and with his former student, Mayar. I can't remember how to say his last, Sharifi Mood, I think is how you say his last name. Great guy. He's at the University of Texas right now. And we all worked together over the last few years to complete these maps for all the major counties along the Wasatch Front, mapping liquefaction triggering and lateral spread displacement at 3 return periods commonly used in design. And these maps were completed earlier this year. So Steve covered a lot of this, so I don't need to really touch too much on it. These are the inputs that we require for this updated liquefaction hazard mapping procedure. And a lot of it is done in GIS, so incorporating LiDAR data and then developing, using that LiDAR data to develop digital elevation models from which algorithms are developed to automatically calculate free face data used in the empirical lateral spread model. And also incorporating the most modern, updated probabilistic seismic hazard information made available from the USGS. So for this mapping, that was their 2014 seismic hazard update, which these maps incorporate. So we've seen this model before. This is the Gillens and Bartlett update of the multilinear regression lateral spread model. And we're going to do a little bit of algebraic magic with this model to show how we incorporate it into a probabilistic framework. If we take this empirical model, we can basically break it down into two basic components. If we take all of the parameters that deal with the earthquake itself, so these are earthquake magnitude and source to site distance, those parameters are all seismic loading, and we can group them together and just call them L. L is the apparent seismic loading parameter, and it's similar to a modern attenuation relationship or ground motion prediction equation. That means that everything else that's left has to do with the site-specific geotechnical and geometry, or the slope or the free face of the site, and we call that the site parameter, or this is labeled G. So that equation then becomes a simple summation of L and G. So if we want to throw that into a performance-based approach, we can use then a hazard integral like this, where we compute the probability of exceeding different lateral spread displacements given a known or an assumed site parameter G, and then the various loading parameter L for the various areas that we're mapping. And this loading parameter L, even though it's not a parameter that we can measure with some instrument, we certainly can calculate it. And it really is a function of where you are located relative to the seismic sources. So here's just an example that Mayar and Dan prepared a few years ago of showing 4 different locations in Utah County. And it just shows that depending on where you are in the valley, your computed hazard curve, or your mean annual rate of exceedance for L, will vary because your location relative to the causative faults varies as well. So all of this is accounted for when we develop a grid across the Wasatch Front. So this is the workflow that Dan and I developed for the creation of the lateral spread hazard maps, where we incorporate the geology, we incorporate the surface geometry, and we incorporate, that's the free face and the slope raster. And then given the geology, we go and randomly select geotechnical properties from that mapped geologic unit. And we repeat this tens of thousands of times in order to create basically a population, a virtual population from which to get our probabilities from. And as we do that and incorporate the loading parameter that was calculated across, or at least for that specific pixel in the raster, we can then develop a virtual hazard curve for lateral spread displacements, from which we can pull then the predicted displacement at the return periods we're interested in. And we do this across for every grid point in our map, essentially across the value or across the valley. And so we're literally performing probably tens, if not hundreds of millions of calculations to develop these maps. And so here's the summary maps that were developed for lateral spread. And I wanted to plot all of the counties at the same time so we can just kind of get the bird's eye view of how things are changing. The map on the left is the 475-year map, or that's the 10% probability of exceedance in 50 years. The middle map is the 1,033-year return period. That's 7% probability of exceedance in 75 years. And the right map is the 2475-year return period. That's a 2% probability of exceedance in 50 years. And so we definitely see some interesting trends where, again, most of the displacements are isolated to specific locations, usually near major river deposits, alluvial deposits, the northern portion of the Salt Lake Valley, near the Salt Lake Airport, around the margins of the lakes, or the Great Salt Lake, and then much to do up in Weber County and the border between Weber and Davis County in the vicinity of Hill Air Force Base, South Weber, South Ogden, and Ogden City. When we get to the higher return periods, we see significant problems, the potential for significant problems all throughout the valley. And that is really commensurate with what previous studies have identified. The nice thing about these maps, though, is, again, we've assigned actual displacements to these maps. And so that helps us to quantify what we're looking at with the various colors. So we've Dan and I developed a similar workflow for liquefaction triggering. And this workflow was largely based on previous workflows that have been developed by Steve and his earlier students. A very similar thing, but this time we're looking at factor of safety, assuming that a layer of soil somewhere in the soil profile will trigger in liquefaction. And so that's really, when we look at factor of safety, what we're assuming, that there will be a layer of soil somewhere beneath the ground surface that does trigger in liquefaction. So here are those liquefaction triggering maps, again, for the 3 return periods of interest. And we see a lot of the similar behaviors, not identical to lateral spread, because they really are 2 different hazards, even though they are correlated and related. But we do see essentially a couple real problem areas pop up, which is, again, I would say the populated portions of Weber County, Ogden City, the west portions of Weber County, the northern portions of Salt Lake County, downtown Salt Lake, the vicinity of the airport, It looks like the 201 heading out west. Those are all areas that map as high hazard for liquefaction triggering. And then following the Jordan River down into Utah County, we see the Spanish Fork area has the highest hazard for liquefaction triggering, followed by some portions around the lake in some of the regional portions of Orem and the northern portions of the lake. When you get to the high return periods, we see a lot of hazard in a lot of different places for liquefaction, which we would expect to see given the lacustrine deposits, the very soft or loose soils that are down there, and the high groundwater. And so this output is what we anticipated to see. So that was nice. The difference, though, is the level of detail that's in these maps. It's pretty significant. So I know one of the things we really want to discuss are the practicalities of these maps. What do they mean? How should we use them? How should we not use them? And so I wanted to address some of these points and questions here. What should you use these new maps for? Well, first, I think they're excellent to be used as a preliminary consideration for liquefaction hazards, specifically triggering and lateral spread displacements, prior to the availability of site-specific geotechnical data. I cannot emphasize enough that these maps are not and never were intended to replace site-specific analysis. These maps were instead developed as a regional tool and as a first-order estimate of liquefaction assessment. They should be used to help guide public policy, emergency preparedness, and zoning decisions by counties and cities and municipalities. And they can be used by engineers and consultants and contractors for the consideration and development of your geotechnical site exploration plans. Give those engineers an idea of how much exploration they should perform, given the potential hazards that are in play in that area. Now, what should we not use the maps for? We shouldn't use them as a replacement for site-specific liquefaction hazard assessment. We also should not use them as a replacement for specific geotechnical engineering recommendations without any accompanying site-specific hazard analysis. So just a couple of conclusions. These new probabilistic triggering and lateral spread maps are developed and are now available for Weber, Davis, Salt Lake, and Utah counties based off the most current available USGS data, the 2014 updated probabilistic data. These maps are created on a 0.05 by 0.05 degree grid across the Wasatch Front, making these arguably the most sophisticated and detailed liquefaction hazard maps in existence in the world today. They also incorporate the most recent seismic hazard data from the USGS, as well as the most recent publicly available aerial LiDAR data captured and made available by the state AGRC. And I would just like to emphasize that these new maps, they're a powerful resource for many individuals, for engineers, owners, public entities, emergency management personnel, policymakers, and many, many others. And hopefully they will be for years to come. I do want to emphasize what Steve said, is that these maps are living, breathing creatures that will need to be updated someday, just as the Anderson and others maps needed to be updated as well. And so as more information becomes available, someday we'll need to update the maps accordingly. But fortunately, these maps gave us a really good roadmap of how we can proceed in the future, and hopefully updating them in an objective and a logical way. So that's all that I had, and I'm happy to answer any questions. And maybe, David, this is a great place for us to open up the larger discussions about what we were discussing, namely, where do we house these maps? How do we make them available to the public? And those kinds of issues as well.
That's a good segue. I guess I'll say something first, and then others could chime in. So I get to begin with, we know that Kevin Franke and Steve Bartlett have submitted their final report that have these 4 county maps in it to USGS, and then UDOT will also publish the same report, kind of, I guess, as a co-sponsor. We'll publish it on our website as the kind of the documentation of it, I guess, the PDF report, the research report with the maps included. As far as where they go from there, we had a similar conversation, about 3 years ago when you're done with the Utah County maps. And I think UGS, perhaps Jessica, I can't remember, said that they could work on, when they had time and resources, they could work on making those maps, those Utah County maps, available in a more of their typical format for the public, from their perspective. I guess here we are again. Maybe this is the renewal of that conversation. Where does it go from here, and does UGS want to have a role in making these available in their format?
I think that as far as the UGS goes, we can look at making them available, and it would probably be a little bit more streamlined now. In the past, having to present them as a full report and go through our review process and make all those edits was a little bit more involved. We've just rolled out our online hazard mapping portal where we could at least show the maps and then link to your original reports. That way they'd be available in this, online portal with all of the hazard mapping that we're working on, as well as other state agencies and other data that we're getting in. So it's a possibility that if we have the GIS, we can house them there and make them available to the public and consultants.
Well, that sounds really great. Maybe that begs the question of what format could the maps be provided in, and from your team, Kevin?
Well, can you still hear me?
Yes.
I don't think I'm muted. Okay. Well, we can provide the data in a variety of formats, and Dan will need to chime in on this as well. Right now, they're just in image format, but I believe we can provide them as a raster as well. Is that correct, Dan? Could we provide a GIS raster for these different return periods and these different hazards?
Yeah, the maps that are presented in the report, in the PDF report, those are all drawn using Esri ArcGIS software. So we have all of the results in raster grid format. I could output them from ArcGIS to whatever format you like, but if the UGS is using ArcGIS, then it might just be a real simple thing. Just give you the GIS files, and you could incorporate it how you like and however you want as a layer in one of your one of your web map utilities or whatever you need to do with it. But I'm happy to export it into whatever format you need. I really think that that's something that should be done. And honestly, I think that's a next step, is if we want to get the maps out to the public, especially to those people that Kevin listed, the people that would benefit from them, making them available digitally is really important. It'd be great if there was a way someone could zoom in an area of interest and see the detail. I think one of the unfortunate things, it's just the nature of it though, is in the report, we're showing the maps at a very large scale because that's that's what we can do. But if you were to zoom in, you'll see there's actually a lot of detail. They're drawn at a very high resolution. So making it digitally available, I think, is really important.
On
Hey.
did it freeze up? Can you hear me?
Yes, is that Jessica?
Yeah. For our online hazards mapping portal, GIS data would be what we would need. We would need to get together and talk about the tables. So we link the GIS data to some tables that can feed into the code to go into there so that all of the attributes will show up. So people could zoom in to specific locations, or they can search by address and go to a specific location that they're interested in. And then we would need to kind of develop the tables that would feed the attributes to tell them, you know, if it's high, moderate, low, and kind of whatever other information you would want to give based on where they click in there. So there'd be a little bit of kind of back end development, but as for the mapping itself, it can just feed right in.
Yeah, Jessica, I don't think there's any tables associated with the maps. They're literally just a raster that so there's like, it's just maybe layers of rasters that someone could query, and it would give you a value. So they're numerical. Like you click on the raster and it's going to give you either a displacement value number, like how many meters it would displace for a lateral spread hazard map, or for a factor of safety hazard map, it'll just give you the factor of safety number, some number between 0 and like 10 or whatever it is. So it's no linkage to tables necessary, but there would be some back end work probably to get those rasters incorporated into your web tool.
Yeah, on our end, we would have to incorporate that data from your raster into the table format that we're using to feed the app itself. So
Okay.
we'd have to do a little bit of taking your data and putting it into the right format to get it in there. So that could take a little bit of time, and we'd have to work with our GIS person and myself to kind of massage that to get it into the right format, but it's definitely something that we could do.
Could we also make the GIS, these raster layers, available for someone to download, so they could just actually pull it right up onto their, or connect to it via some sort of server, so that they could display it on their desktop?
Yeah, let me send a link to our portal in the chat here, and you can look at it. It has the capacity to create a report, so you can draw a bounding polygon and create a report for that area, and it can fill in with whatever sort of information you want in that report. We'd have to work on a format, but you can look and kind of see what we've done in there in terms of our liquefaction mapping and the other hazards that we've mapped. So on the main page, you can kind of click around and just get quick information, or you can download a report that has more detail.
That sounds great, Jessica. Thank you for thank you for giving more information on that portal. Sounds like that would be a great place to host the new maps, or to make them publicly available, for that matter, in the GIS format. Was there any more discussion needed as far as connecting who could coordinate with whom? It sounds like maybe Dan and Jessica could coordinate directly, or maybe through Kevin or Steve. I'm not sure.
I think, Dan, Dave, you need to realize that this additional work you're talking about, I don't know, correct me, Kevin, is it in your contract or is it out of scope?
Well, I don't think it's explicitly called out in the contract. However, if all we're doing is a data handover, I don't think it would entail or require any additional contract changes. I would become more concerned if we have to begin to change the data, reformat the data, transform the data somehow to make it compatible. Then it becomes something that requires a significant amount of time and effort.
Sure. Well, so it may be that you can talk through that as government agencies, but it sounds like there still may be a little bit of additional work that may be out of scope that's unfunded, but I don't think it's a lot of effort. It's just something that needs to be considered.
Okay, thanks for pointing that out. And sounds like maybe we need a little time to get more familiar with the portal and see what see what it looks like, see what kind of examples are available, and maybe that would inform Kevin and Dan and Steve or UDOT to maybe chime in on what is needed, what kind of support's needed to make that new data available in that portal.
Yeah, I wonder if all of our results and work are stored in a ArcGIS geodatabase. And I wonder if we could hand off the geodatabase. I mean, I think it's pretty well organized and labeled, and projections are defined, and everything's attached, all the metadata. We could hand it off for someone to look at and just get a sense of, and then they could let us know if they need anything or have other questions. We could iterate from there.
That would work if you wanted to, send it to us and at the UGS, let us look at it, and we could see how much would be involved with taking your original attribute tables and coming up with a coding system to make them fit into this hazards portal. And we could kind of see how much would be involved with that.
Okay, that sounds great.
Okay, wonderful. We also had a similar question from Rick Chestnut, a consultant, asking who and how do we connect with to get a GIS copy of the maps to incorporate into a GIS platform. Rick, are you talking about kind of a separate effort from what we were just talking about, as far as having it handed to someone else besides what we're trying to make publicly available?
No, I think after I posted that, I think there was a good discussion about that. Yeah, I was looking at an opportunity, and I think you discussed it, having that available to import into GIS as a layer and use that that way. So that answered my question.
Okay, great. Any additional questions, comments on that kind of subtopic of availability or access to the maps, as well as anything you want to ask from Kevin Frankie's presentation? I hear silence, so I'll ask a simple question again. So we had some good background today on how some of this originated as far as priority research and hazard map development based on ULAG and UGS kind of oversight. Are there additional steps in that process that would warrant new attention, such as Cache County or other counties or other types of related earthquake hazards that agencies could help fund here locally or in the state of Utah?
I think it's a good question, Dave. Couple places, Cache County pops to mind still. I think the reason why Cache County never got mapped is because Utah State, after kind of the retirement of Lauren Anderson, became somewhat inactive, I think, in doing this. But Cache County probably be consideration, and I'm wondering if some effort should be made in Washington County.
Yeah, I would agree with that comment, because I think we've seen Washington County explode in population in recent years, and they're right along the
Hurricane Fault.
I call it the seismic corridor, right? And
Hurricane Fault. So.
Yeah, so that it's a major population center in the state. So I think even though it wasn't originally on the list, I think it would behoove us to reconsider that now, given the changes in the population that have occurred.
As a consultant, I would support that. I think a lot of work up in Cache Valley with development there, that'd be a great resource to have, as well as Washington County. I think those are the areas that are really growing, and we see a lot of work going on. So that'd be very helpful with the consultant pool.
Looks like we also have a suggestion of Tooele County, ? From Jeff Gilbert.
Well, since I live in Tooele County, I don't think it's a bad idea. I think it's just a matter of how you organize priorities.
Right.
Certainly, many other outlying counties where there's population density could benefit from these maps. I think it's, when you go with the USGS, the issue will always be with the USGS when you seek NEHRT funding is you have to have some component of research, meaning every time we've gone back to the NEHRT program, we've actually changed the mapping method significantly, showing how they're going to be updated. When we get to a point where we're not doing that and maybe now just applying the current technology or mapping methods to new counties, they'll turn around and say there's no new science in this and they will not fund you. So the onus now turns back to the state and counties and municipalities of, to come up with the money to do the mapping. So I think it's a question more of funding than it is a technical question, frankly.
Yeah, I agree with that. That's one of the reasons why we've had to remap a few of the counties up to this point, is because in order to convince the federal USGS to give us money, we had to change the method. And so it became, from one county to another, became apples and oranges. And that was one of the goals of this study, was to, okay, now that we've got a study down, let's unify all these counties under the same methodology. But if we were to go back to the USGS again this next year and say, hey, now we want to apply this to Cache County, we would get slapped down.
Well, that makes sense, and it sounds like that makes it quite challenging to round out the state or the urban areas. But
well, maybe not, because there's still some possibilities through FEMA, through the Department of Public Safety and Division of Natural Hazard, Bob Carey's group and Brad Bartholomew. They have ways of getting grants. But I think we now have to partner specifically where municipalities take the lead and say, we really want this, and go after some of these grant monies. So it may be that we have to explore different avenues of funding. And certainly, getting a consortium of different funding. We've certainly had some success with water conservancy districts. Certainly, I think some major contributions could be brought forth by utilities, both gas and electrical utilities. I think you have to build a consortium. Probably, correct me, Kevin, I think when we talk about a county, I think we're talking close to $100,000 to do this. By the time you get the data collection and do the calculations, but I think that's the neighborhood of the level of effort in terms of monies that you're looking at.
Yeah, if we assume a typical overhead taken by the universities, that is correct. If we find a way to have a reduced overhead or something like that, you might be able to get away with less, but we usually don't advise it. I mean, I always tell sponsors of research, you get what you pay for. And research through universities can be very expensive. So yeah, I would say no less than 100, and more realistically, if we're involving multiple universities with different roles like we did in this current project, it's probably closer to between 100 to 150,000.
Yeah, there is an economy by going through UDOT where the state overhead for state contracts is much less. I think all universities have negotiated only a 10% overhead. But it's a little bit of a challenge. You know, state agencies would have to take that on and then send the funding from the state agencies to the universities that route. We can get some economy that way, but when you start mixing public and private sector monies, it gets really complex, and different overhead rates will have to be applied. Most universities for private and non-governmental, meaning state government agencies, are going to be charging slightly over 50% overhead on those contracts.
I wonder what,
in addition to labor.
With the new earthquake that we had and so forth, with the damage we've seen around the valley out in the magma and so forth, I wonder if the counties are a little more apt to be interested in something like this and put some money into it.
My experience with counties is they don't have a lot of money.
Yeah.
But I think what counties can do is apply for FEMA grants. But the counties have to take the lead and like the grants. I can't write a earthquake hazard reduction grant for FEMA as a university. The key really is if you're going to go the county route, is I think they can still tap some federal monies, is they have to take the lead in the grant writing. We can assist, but they have to take the lead, and they have to be the one that's seeking the monies. But I think we could bring Brad Bartholomew a little bit into the discussion, Dave, and see what there might be possibilities to do in getting additional FEMA monies in through grants to do some of this mapping.
Okay. Good idea. Is that the type of thing that you would normally address at some level at ULAG meetings that perhaps still happen annually?
Yeah, we haven't had them the last couple of years, but I think it might be worth, reconvening. They normally are held in February. We can have an impromptu one. There's no reason why we have to wait for February, but I think we need to convene as a committee and discuss this, and probably bring Brad Bartholomew and Bob Carey into this conversation in combination with UGS and universities, and see, okay, is there a need? What are the funding mechanisms, and so on and so forth. But usually the ULAG meetings are held in concert with the NEHRP. Since we're not seeking NEHRP funding necessarily, then I think we could go ahead and do this on our own, but still use it under the auspices of ULAG, because I think that's the easiest way to bring the key players together and talk about funding needs and mechanisms.
Okay.
It seems like Washington County is still a really good one there, because it's a little more seismically active, and they've got it's a high population area, and the infrastructure, they've got quite a bit of infrastructure.
And they're planning a new pipeline, are they not, in Washington County to bring in water from Lake Powell? So
yeah,
time.
Yeah, if any county might be interested, that might be a good one there. So.
That's a good point. Good suggestion.
I also thought of Wasatch County, but I don't think it's quite the same as Washington County.
Yeah, the susceptibility is a little less up there too. Not that there's not some localized areas, but they don't have these as broad of susceptibility, I think, as you would see in some of the Wasatch Front counties. But it still needs to be done. It's just, again, which ones do you prioritize and where do you get the funding to do it? We've benefited greatly. We benefited greatly from NEHRP, but I think the NEHRP avenue is not completely closed, but it's hard to find NEHRP monies and recommend them on a scientific basis.
Okay, thanks for addressing that question on what's next as far as research or mapping. Are there any other questions for Kevin Franke on the map development effort, or for Steve Bartlett on I guess on either presentation before we try to wrap up? Maybe while you're thinking what your question is before we end here, I was going to ask Steve, and you can tell me if this is better discussed offline. I know we can discuss it offline, but if you want to address it now, we have a little bit of time. I understand you have some additional reports from, I guess we'll say this effort, but it may be from some side efforts. Do you want to talk about what those are, and just so we can understand what they are when we go to talk about making those available?
Yeah, I can talk about two maps that we have. Again, they're more scenario maps, so they're not probabilistic completely. They have some dealing with probability on the geological factor side, but in terms of seismic hazard, they're considering an event. As part of Davis County mapping, this was being done by my graduate student, and I told her that I cannot really give her an MS degree solely on just data collection. So she did a deterministic or scenario map for Davis County. It was not in really the scope with UDOT, because with UDOT, all that was required essentially from our point for this last mapping effort was just data collection, we being in the University of Utah. So I have that available. It was done, I guess, with not any funding, but I think from a standpoint of a map and also a way to compare maybe a little bit of the deterministic probabilistic maps, I think it has some value. So I've offered it to UDOT for publication, but you decide whether you want to do that or not. It's certainly published by the university as part of her thesis, but that's not going to be very widely disseminated. So that's a possibility. And then Jessica, I think if you're still on the line, I still have not had the UGS publish the scenario map that we developed for Salt Lake County and had reviewed quite extensively. I've thought I've sent back my revisions to that report that you and Steve Bowman had made comments on, and that needs to be published some way or another.
Yeah, I need to follow up on that, see where it's at. We did get it reviewed, and it kind of came through at this time that we were transitioning from putting out hard copy PDF reports to going to this online hazards portal. Pretty much most of our reporting and publications that we put out now are all going to be online. So I'll follow up on that and get back with you on if we want to publish that as a PDF.
Spent considerable time addressing both you and Steve's comments. I spent almost a whole month of time on that. So hopefully it's pretty close. Yeah. And I think you hopefully still have the ArcGIS files that we developed when we showed that to Salt Lake County. So I think we're close, but I'd like to close that loop. That should be published too, in my view, because right now, in terms of hazard ordinances, it is kind of the de facto map, at least that Salt Lake County is using. So it still needs to be out there as we transition possibly from these newer maps, which are probabilistic. That's a whole different discussion, but I think that needs to be available because I know there are consultants using those maps.
Yeah, I'll follow up on that and get in touch
Okay.
with you, and we can go from there. Just a little bit discussion of kind of next steps. I can look at having a ULAG meeting to discuss those next steps.
That would be great.
Wood County would be a good next step to look at mapping. The geologic mapping is a little bit older out there, but we do have some fairly recent mapping, and we're looking at doing hazards mapping in that area as well. With the Magna earthquake, we have some areas of observed liquefaction in locations that I think were determined to have kind of lower probabilistic ratings on some of the maps that were done. So I'd like to look into kind of correlating this observed liquefaction data with the subsurface geodatabase that we're putting together with UDOT. And that could be an angle that we approach for funding, taking this subsurface geodatabase and correlating sand units across the valley in certain areas to look at where liquefaction may be higher than previously considered because of the assumption that these are all clay consolidated units. The subsurface data gives us the ability to map thick sand beds in other locations to kind of go about that. So that could be an angle.
Yeah, I think in terms of Salt Lake County, my recollection for the northwest quadrant, the geotechnical data was relatively sparse. So the fact that we've had observable liquefaction and maybe some more geotechnical development, and I don't think our maps had any of Rio Tinto's data in it, which is actually in the public domain. I think there could be some improvements in that quadrant, no doubt about it.
Yeah, and the geotech is still fairly sparse out there. We do have more with the inland port and prison development, but it's still pretty limited out there.
And you said Tooele County in your first comment. Is Tooele County you thought what you'd like to do work on?
Yeah, I think Tooele County would be a great step to kind of start on since we have the whole Wasatch Front. There's definitely a hazard there, and
it's still developing. It's developing rapidly. Yes.
Yeah, it is.
Jessica, that sounds great. Sounds like you're willing to put together a ULAG meeting in, I don't know if it's the near future or if this is planning for next year, but I guess whatever timing makes sense for that group to discuss some of these follow-up items.
I think we ought to meet early fall, Jessica, for a couple of reasons. We haven't met for a couple of years, and I think we still have some things to do. And particularly with, the recent vet and Magna, there might come out some additional things that need to be done, not only in mapping, but other liquefaction evaluations and that. And also, I'm not around in February anymore because I'm in Korea every year. So I think we need a change in leadership too. And I think it's fair to, meet and maybe start that process too, at least ahead of the committee. Change the chair of the committee.
Okay, maybe we can look at kind of mid-fall and play it by ear, see how it's going, if we're back to meeting in person or if we want to kind of set up a virtual meeting similar to this. But it could be interesting to have some of our field people discuss where the liquefaction was that they observed and go over. Look, I think there was a little bit of lateral spread out near the tailings ponds, things like that. So kind of a discussion of the Magna earthquake and how we'll go forward as a group. So maybe mid-fall, look at something like that.
Yeah, September sounds fine. I wouldn't get into October, but I think give the schools, you know, we at the universities a chance to kind of get August past us, but sometime in September sounds great.
Okay.
All right, sounds like we're making good progress, making good connections, and making a plan forward. So thanks everyone for your input and for your participation today. Are there any final questions before we close this presentation meeting? All right, well, I will say on behalf of UDOT, thank you very much to Steve Bartlett and Kevin Franke for their presentations today, and for all of your participation in the study as well as in the meeting today. And appreciate all the hard work that was put into this latest mapping effort for liquefaction hazards here in Utah, and look forward to great things in the future from this group. So thank you very much, and we'll go ahead and end the meeting.
All right, thank you.
Thanks, guys.